So I'm pretty sure that there's probably a lot of scientists that are already working on this and stuff. But I was just kind of curious on how like a certain mass like travels through time and stuff.
Okay.
And so the way that I saw it, kind of, I don't know if you can see this. It's that one right there. That one, like a more massive object travels through time. It like pulls the flow of time together, which makes stuff travel slower through time. But like if it's less dense, then it doesn't have as much of a pull on the flow of time, so it like widens time flow, which makes stuff go faster through time.
Okay. So when you say travels through time, what exactly do you mean?
I don't know, just the way it travels through time from like one point to infinity.
So everything travels through time, right?
Yeah.
So you're saying that if something is near an object that is very massive, that it experiences time differently?
Yes, it'll experience it the same way that the more massive object experiences it.
Well, yeah, but isn't it true that a massive object is actually it actually consists of many non-massive objects pushed together?
Yeah, but it's
Okay,
the mass as a
so
whole.
a massive object may have different gravity at different points along it, unless it's a single point like a black hole, right?
Yes.
If you have an object like Earth experiences different gravity at different points on Earth.
Really?
Because different point, yep.
Oh.
For instance, high in the Andes Mountains, gravity is a little bit less than on the ground. And if you're exactly in the center of the Earth, then the gravity pull on you is equal in all directions. And so it's actually weightless on an object at the very center of the Earth. But a black hole is a point. So it's for a black hole, it's completely uniform. I was just pointing out that if let's say you have two things, let's say you have two objects, let's say you have two neutron stars, and they're orbiting each other, very close to each other. Then you'd have different gravitation at different points between the two neutron stars, or at each neutron star, and so there'd be different time experienced at different parts of the gravity well. In other words, time relates to the gravity well that you're in at that point because of the bending of space, right?
Yeah.
That's what you're saying. Okay, now this is I think this is well known. I mean, I think that this is part of the general theory of relativity. Have you looked that up?
Yeah.
Okay, so they would have talked about that, right? Right. Google general theory of relativity and time. I'll bet what you're saying is discussed. So I mean, I think you're right that the flow of relative time is different depending on the magnitude of the gravitational field that you are in. I'm just quickly looking it up, but I think you're right. I think it's probably on Wikipedia, actually. that doesn't. I think what happens is that under higher gravity, it's exactly like being in a high acceleration. I think what happens is time slows down. Is that right?
Yeah. What I was saying is that when there's less gravity, time is not as fast. Yeah.
Rotating masses drag along the space-time around them. It's called frame dragging. That's rotating masses. Gravitational time dilation. Clocks run more slowly in regions of lower gravitational potential. This is called gravitational time dilation. Gravitational time dilation is the effect of time passing at different rates in regions of different gravitational potential. The lower the gravitational potential, which is closer to the center of a massive object, the more slowly time passes. Albert Einstein originally predicted this effect in his theory of relativity and has since been confirmed by tests of general relativity. This has been demonstrated by noting atomic clocks at different altitudes, like high in the Andes, for instance, will eventually show different times. The effects detected in such experiments are extremely small, with differences being measured in nanoseconds. But of course, if you're talking about a black hole or something like that, then it's going to be a much bigger effect. So I agree with you. Is there anything else that you predict?
Oh no, that's impossible though, because time's not linear. One thing that